Let us look at another example. Example 2. We'll construct a network diagram, but this time with more predecessor activities. We are presented with a table with activities A to I, with predecessor activities, but this time we have a number of them and with duration in days. The normal thing to do is to sketch the diagram first before proceeding with the precedent diagram. So we start with A, which has no predecessor but acting as a predecessor to activity B and C. So they are connected or in a relationship. Activity B and C also acts as predecessor for activity D and E. Activity F has predecessors as B and C. So the linkages are there. And activity G, H, and I all have predecessors. So for activity G, it has a predecessor of D and F, and activity H have E and F as its predecessors. So we have the linkages. And activity I has predecessors as G and H. So this is how our network diagram should look like. And with our PDM notation, we shall commence the drawing of the precedent diagram. So we have this following the sketch. We have this as our diagram and the relationship. Now we have our precedent diagram well structured. We shall commence with introducing the durations for each activity. So activity A3, B4, C2, D3, E5, F2, G4, H is 6, and I is 2. We shall now commence with the forward pass calculations. So starting with activity A, we start with 0. 0 plus 3 is 3. This 3, which is the early finish of activity A, becomes the early start of the succeeding activities. So B has 3. 3 plus 4 is 7. And C has 3. 3 plus 2 is 5. And we move to D. 7 moves to D. D plus 3 to give us an early finish of 10. And E has activity 5 to start as its early start activity, giving us 10 as its early finish. Now for activity F, the highest should be taken because these two activities have to be completed before F commences, which means the last activity to be completed is activity B, and therefore 7 would go to F as the early start, and 7 plus 2 gives us 9. Now let's look at activity G. There are 2 linkages or 2 preceding activities to G. The highest to be taken 10 instead of 9 because 9 will finish before 10. So 10 will then become the early start activity, early start for activity G. And that plus 4 is 14. And for activity H, it will take the early finish value of 10 from activity E. 10 plus 6 is 16. Now, which one goes to I? We still take the highest because H will be the last activity to finish between H and G. Therefore, 16 goes, adds to 2, it becomes 18. This completes the forward pass. Let's look at the backward pass. So we repeat 18. 18 minus 2 is 16. And then 16, which is the latest start, then goes to G and H. So we have 16. And for H, the late start will be 10. That is 16 minus 6 is 10. And then for G is 12. Because 4 minus 16 is 12. Now, activity G has two predecessors, and H also has two predecessors. Between G and H, the predecessor is F. What value goes to F as its latest finish value? Let's look at how it is done. So for D, 12 as latest start goes as latest finish for D. And for F, we take the least value, and then for E, we take 10, which is a direct linkage from H to E. Now let's calculate their latest starts. So for D is 9, for F is 8, and for E it's 5. Now between activity B and C, which has 3 activities linked to them, we shall pick the least values among them to be their latest finish. So for activity B, for activity C, we choose 5 instead of 8, and for activity B, we choose 8 instead of 9. Now for C, 2 out of 5 is 3, and for B, 4 out of 8 is 4. Between B and C, we choose the least to be the latest finish value for activity A. It is 3, and 3 minus 3 is 0. Now let's compute the float and determine the critical path. So for activity A, we have 0 as its early start and 0 as its latest start. For activity C, E, H, and I, they have the same value for early start and late start. So their float will be 0. Now for the other activities, B, D, F, and G, they will have different float values. So let's look at them. For B, we have 1. For D, we have 2. For G, we have 2. And for F, we have 1. So the critical path, which is the path with 0 floats, or the longest path through the network, is A, C, C, E, E, H, and H, I.